So just I'm sharing the one note. Okay, in the last lecture, so these things we have seen. So one problem. Taylor's theorem's problem. Question is that the function is, am I audible? One note is visible. Confirm anyone?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. The function fx is equal to sin x is approximated by Taylor's polynomial. Okay, we can say that is also Taylor's polynomials of degree 3 about the point x is equal to 0. Question is that find c such that the error satisfy this modulus values are 3x. Okay, we have seen in the Taylor's expansion is less than equal to 0, 0, 1 for all x in the interval 0, comma c. Okay, so in this case, means the function given sin is approximated by Taylor's polynomial of degree 3. So we not write the Taylor's theorem sum of 4 degree. Okay, just we stop in 3 degree. Okay, so 3 degree in that sense. So there is also R3. Okay, R3 is written. R3, that means it contains the 4 degree x. X variable is the 4 degree. Because this error is encountered when we are taking the 3 degree polynomials. So that R3 contains the x to the power 4 upon factorial 4. Okay, I will write that one. About the point x is equal to 0. So when we talk about the point, so we consider the limit like in this interval because it's not given interval like in the first 0 and x. Okay, so we have to write the about the point 0, x is equal to 0. So we consider interval 0 and x. Find c. C is the value such that error will satisfy for all x for x in the interval c. So that means this c is what is the maximum value of this given interval. So that means x is ranges from 0 to c. Okay, x ranges from 0 to c because c r3 is the function of x. So maximum on the maximum means what we take in this error range, what could be the value of c. C, that means the in the maximum value of this interval 0 to c. Okay, so first by the Taylor's expansion or theorems, we can write up to 3 degree a plus remainder. Okay, so now we write by Taylor's theorem. But Taylor's theorem is enough, but it is written that degree 3. So now you can write this is the Taylor's theorem. The function we have to write sin x about 0. So what first you write the Taylor's theorem fx Taylor's theorem about x is equal to 0. So these things we can write. Okay, now this is f0, so not equal to this plus next is what we write x minus 0 power 1 factorial 1 f dash of 0. This is the power 1 x minus 0 whole square factorial 2 double dash of 0 and x minus 0 whole cube factorial 3 and plus now the next term is remainder is x minus 0 power 4 upon factorial 4 and f uh, it is I forget to write here third derivatives triple dash of 0 and here is the fourth derivatives, that is the remainder term. What we write, so here we write okay error satisfy this one, so we can take here c. Okay, c is what now for this interval which is belongs to 0 to x. Okay, it's better to write the something else like not make confusion, something theta, and this is theta. So therefore this f of x, so this is our sin x. So you write here sin x is equal to f of 0. Okay, okay, we are living here x factorial 1 f dash of 0 x square upon factorial 2 double dash of 0 plus factorial 3 triple dash 0 and plus this is x power 4 factorial 4 theta. Since fx is equal to sin x, so therefore f of 0 is equal to 0. F dash x equal to sine differentiation of sine is cos x. Therefore, f dash of 0 is equal to 1. Okay, we have to put the values. F double dash x is equal to cos is minus sin x. Therefore, f double dash 0 is equal to 0. And f 3 times 3 derivatives is cos x triple dash of 0 is equal to minus 1. Okay, so we can write this. Now fourth derivatives of x is equal to this is sin x, and therefore a fourth derivatives of theta is equal to sin theta. Okay, so we have calculated these all derivatives at the given point at x is equal to 0. Okay, next what we do, we take all these values. So on using above values in the equation, question number you say it number 1. Then we have, so this is sin x is equal to, so f0 is 0. Okay, next x upon factorial f dash 0 is 1. So we write here plus x. Next is x square double dash. So f double dash again 0. We write 0 is here. And 3 times derivatives. There is minus 1. So you write here x cube upon 6. And this is minus 1. And plus x power 4. And this is it's a factorial 4. Okay, so 3 is 24, and this value is what I've written cos. Hmm. Here we use the sin theta. Sin theta. That's it. Yeah, means where is L, R, and of x is this is theta is equal to no, it is wrong. This is x power 4, 24 sin theta, where theta is less than, sorry, x in greater than 0, theta is less than x in greater than 0. So I have this Rn function remainder term. Sin x is equal to x plus minus s cube 6x power 4 by 24 sin theta. Okay, so this is our polynomials, but we are now talking about the only in error. So error is what? This one is error or remainder. Okay, so means to say Rn of x is equal to x power 4 24 sin theta. Okay, so these things. But according to the question given, Rn of x is less than equal to 0.01 for what the question for all x belongs to interval 0 c. So therefore, x to the power 4 upon 24, and this is sine c. C is the uh, value we can consider. Okay, okay, no issue. Means we can take a theta first. Okay, why are we writing this theta? Modulus less than equal to 0, 0, 1. And we know that this theta is lies between x and greater than 0. We know that. And here x, okay, x is lies between this one. Uh, so what we see from this term means when we are taking the value, okay, one more time writing 24, this modulus value and sine of theta less than 0.001. Uh, so this is also the maximum value x. Theta is like the maximum value. So when we compare in the maximum, okay, in max of c, so x is maximum is what belongs to this one, okay, is equal to 0. This x power 4, 24, okay, and this is theta. This is also 1x. Theta is 1. Uh, product we will be writing max of sine theta where x is less than equal to 0. See, this is the here. Okay, leave it. We are not counting. We stop here. Say it equation number 2. Here theta is less than x and greater than 0. So this is equal to what the maximum value it's become c to the power 4. We can take 24. Okay, 24. And what it's again here come sine of c, because theta is its maximum up to x. So we are taking maximum value c. So we can write here c. This one again less than equal to c to the power 4, 24, since sine c maximum is less than equal to 1. So actually what we have to find the value of c. So that's why we have to remove the other terms by these inequalities. So this is equation number 3. So from equation number 2 and 3 we have, so even in the maximum value of c, it will not go beyond this point. So c to the power upon 24 less than equal to 0.01. So this implies c4 less than equal to 0.024. One more zero. Now c is less than equal to 0.024, 1 upon 4. So by taking the fourth root of this value, so therefore c is approximately equal to the is saying 0.3936. So this is our answer. Okay, this is our answer. You see here in this case, what the things, what is the reason behind why we taken C? Because C, the question is find the value of C, and C is the maximum value of the given interval 0 to C. So obvious, this is the our remainder term. In this remainder term, the terms are we are getting according to the Taylor's Lagrange's form of remainders. We have this one. And after that, for maximum value of C, because on x variable, we how we calculate, we need to in x in maximum value. This is less than, we can write C upon 424, and sin C is in the same, sin C is maximum, modulus sin C is less than equal to 1. So this is this one. Now we comparing these two expression, 2 and 3, we will have, and now we will have the value of C. Okay, so by these inequalities, we are just deriving the, we are solving the problems. Okay, we are not working on equal to sign, working on less than equal to sign and maximum minimum values. Okay, so this question is completed. Similarly, so we have another questions like that we have to establish the inequalities relations, means range of some functions by using the Taylor's theorem. Okay, so in this question, anyone has any doubt something? Anybody?
No, sir, clear.
Okay,
No, sir.
okay. So next question is here. Use Taylor's theorem to prove that 1 plus x square upon 2, which is less than e to the power x, which is less than 1 plus x plus x square upon 2 e to the power x 4x greater than 0. Okay, so in this problem, use Taylor's theorem to establish this relation. Okay, so here is the function is what? E to the power x is the given function. Okay, it is not written, okay, about the which point something is not. So you have to observe there. So what I have to write in e to the power x, in which term we have to write. You see in the relation means established, we have to show that, prove that. So obviously we are writing the given Taylor's theorem about the x is equal to 0. Okay, and then it is possible other point, that means it's give you x minus a, x minus b. Okay, so now we can write by Taylor's expansion of function. Function is what? Fx x for interval 0x. Okay, it is written, not written about the point 0, but we have to write. So now f of what x minus 0 is x is here, and f dash of 0, f double dash of 0. Okay, I found it. X minus 0, 1, 0. That's here. Plus. So this contains e to the power x. You see this one. So one side is no remainder term. One side e to the power x. That means it's containing the some remainder terms. Okay. Okay, no issue. We can remove that remainder terms, but we have to use that the things. So 1 plus x square. Now we are writing for the LHS. First, we writing for the 4 LHS. So 1 degree is okay. In the second degree, x minus 0 square upon factorial 2. So this contain C. 2 degrees. So we have to stop up to 2 degree means second degree x is the remainder term. Okay. And this is f double dash theta. Theta is lies between x and greater than 0. What happens? Okay, x minus 0 whole square f double dash of theta is greater than 0. Now, in this case, just to simplify, e to the power x. So, okay, this is easy one. E to the power x. You can simplify f of 0. This is 1. Okay, or we can do. If you want to write more x, given fx e to the power x. So f of 0 is equal to 1. F dash of x e to the power x. F dash of 0 is equal to 1. And double dash of x e to the power x. Therefore, if double dash of theta is equal to e to the power theta. Hmm. Therefore, e to the power x is equal to 1 plus x, and f dash 0 is 1. Okay, and the other is x square upon factorial 2 and double dash e to the power. So these are the expression. These are the expression. So here what we have to write in terms of e to the power x greater than of this term, and we have to remove the e to the power theta. Okay. One thing we know that theta is less than what x and greater than 0. Okay. Hmm.
Sir, theta should be 0 to 1 now.
Hmm. 0 to 1, when we write e to the power theta is 0 to 1, when it is possible, when we write e to the power theta x, then theta is 0 to 1. So, okay, when we write these things, then we write, when we write only theta, so it is like that.
0 to x, correct, sir.
Or getting this one, when we writing e to the power theta x, then theta is 0 to 1. When we writing only theta, so then means this is the assumption are different here. Okay, it's not means theta x, that means now it's become the fraction. Okay, because this values tends to x there, and with the x and without x, this is the 0 to x, and mm, just a second. 0 to theta x when we take the, okay, no issue. Hmm. Both way we can solve, you will get the you can come in the right position. Okay, since theta is less than x and greater than 0. Okay, someone, any questions or message? So why we take second derivatives as a remainder term? Okay. So remainder due to, because the maximum, suppose you are not taking second derivatives, so remainder terms what you take? Either third, last q was third degree. Yes, so this is what remainder. See, x square factorial 2 to the power theta is what? This is r2x. Okay, it's containing the,
So R1x.
oh no, sorry, r1x, not r2. This is r1x. R1x. Because up to here, this is the 1 degree, and this is our remainder. Okay, remainder, that means R1x. So this in all expression we include only up to 2 degree. So 2 degree we including our remainder we are writing. Okay, we are not excluding our remainder. We are not writing excluding remainder. Okay, you see in the last problems when there is the such type of expressions. So this expression we have to write the including with the remainder. In this case also it's including with the remainder. Okay. See, in the last problem, there is written 3 degree. So 3 degrees we writing there. Uh, okay, in the last problem is what it is mentioned that R3. So R3 containing the 3 degree. Okay, x to the power 3. Sorry, x to the power 4. Okay, it is mentioned in the question. I'm showing that. See, this is R3. So what the expression will come up to? X3 upon factorial 3 and f third derivatives of 0 and plus R3. R3 is what containing the 4 degree terms. So we are moving according to the problems R3. So that's why here is in expression it is not mentioned about the R1 and R2, but maximum is what x square. So this expression including the our this remainder term. So we are not including. But what the things is here, now we can remove e to the power theta so that we make it inequalities with the e to the power x. Okay, now we are moving for that one. This is the reason behind, because we cannot write x when we write x cube upon factorial to the power theta. So is it we cannot find this expression? Okay, so reminder we are including with this degree. So now we take the raise of we know that here x is also greater than 0. So this implies that when we take all this raised to the power exponential e power theta as n e to the power x and e to the power 0. This implies that e to the power theta is e to the power x, and this is 1. Okay, and we know that 1 less than e to the power theta less than sin x. No, no, no. We should not write sin x now here. Now we are adding both sides. The terms which are included 1 plus x. Okay, first we multiply x square upon factorial 2 all the side. Make it bring this relation x square upon factorial 2 x square factorial 2 e to the power theta, and this is x square factorial 2 e to the power x. Okay, fine. Those things you see, x is all are the power of square. X it's not also negative, it is positive, so there is no change in their inequalities. Next things, what we add 1 plus x, and x is also greater than 0, so there is also no change in inequalities. 1 plus x means adding both sides e to the power theta and less than 1 plus x plus factorial power theta. Sorry, x only, right? E to the power x. So we have this relation. So from this relation, if you say this is the equation number 1, okay, and say it equation number 2. From equation number 1 and 2, okay, we have, so what we write? So e to the power theta is e to the power x. E to the power x, which is less than, sorry, e to the power x is greater than 1 plus x squared by factorial 2. Now this is term, and this side you see here 1 plus x square, 1 plus x plus by 2 into the power x. Okay, so this is proved. Okay, so got it this one?
Yes.
Yes.
Yes, sir.
Okay, so we are now using the Taylor series. We are establishing the range of, you can see, with power x. It means to say, so these values for any values of x is lies between these polynomials. Okay. So like that, here is the restriction about the x greater than 0 when x is for all real numbers. So now there is the three cases for x is equal to 0, x greater than 0, and x less than 0. You have to show the things. The next problem is similar to three cases. Uh, in the three cases. So today unable to be continue, just be writing the question. The question next is, so that 1 minus x square on 2 is less than equal to cos x 1 minus x square on 2 plus x power 4 24. For all x belongs to this capital R, this is the set of real numbers. Okay, in this question, it is not written that use the Taylor series or Taylor's theorem. Okay, so you already studied the Taylor's expansion, so only that expansion you have to apply to find to show this expression. Okay, so when x is belongs to R, so there is the three cases when x is equal to 0. First case 2 when x greater than 0, and third case when x is less than 0. Because uh, you have to do when see the x is equal to 0. So what happened? 1 minus x square by 2 is also become 1. Cos 0 is 1 and less than equal to this again 1. So case 1 is easy to means no need to. So when case 1 x is equal to 0, so that means you can write when x is equal to 0, so 1 minus x square cos x and has the same value 1. That's enough. Next we are moving to the to mean satisfy this condition for x is equal to 0. Now next we go for the x greater than 0. So last question we have done in same manner. You proceed ahead, and the next class I will discuss the things. So you try this one. Um, so one more similar to this you can try. Okay, I will solve this cos problem. Similar, the question is that so that so sin x lies between x minus x cubed 6 and x minus x cubed upon 6 5 upon 120. You see, this is the 5, including the remainder term. And here the things are, it is written 0 to x means for greater than 0 you have to put. So only one case is enough. Okay. So in the next lecture after this problem, I will. Okay, one more problem. You write it. Uh, use Taylor's theorem to obtain an upper bound for the error approximation. The question is in upper bound for the error of the approximation. Okay, this question is looking like incomplete. One more question. So I will tomorrow I will tell you what is the find the third Taylor polynomial for fx is equal to cos 6 centered about c is equal to 5 by 3. Okay, this question you can do. Okay, this one is some doubt, so that you can practice. So I will just this problem tomorrow I will solve. After that, we start the Taylor series immediately and Maclaurin series. Okay, in the next lecture. Okay, those who have attendance of today's class, mark your attendance. Would be depends on Q and given RN. And yes, last question was for 3 degree. Yes. That's right. Okay, any question, anything? Okay, in the next
No,
class.
sir.
Okay, in the next
Yes,
class.
sir. Please send the PPT.
Yes, obvious.
Thank you, sir.
Okay, now I'm leaving and I'll send the paper.
Okay, sir.
Okay, sir. Thank you, sir.
Thank you, sir.